Friends, today we are going to discuss about theory of errors. Already we have learned about measurement. Measurement is an important tool of science and technology. The result of measurement by measuring instrument contains some uncertainty. Meaning error. Uncertainty means error. For example, we know the value of gravity is 9.8 meter per second square. 9.8 meter per second square. But when you are doing experiment in your lab, one person, that is one student, can get the value as 9.7 meter per second square. The other students may get 9.5 meter per second square. The third students may get 9.6 meter per second square. But they will not get the accurate one, that is 9.8 meter per second square. This what we can call it as uncertainty. That means error. Now, in measurement, there are two terms. One is accuracy. The other one is precise, with precision. What is accuracy? How the measurement is close to the true value. Is close to the true value. So accuracy is nothing but what? How the measurement is close to the true value is called accuracy. Then precision means how well we measure. So accuracy is how the measurement is close to the true value, and precision is how well we measure. Now we will see an example. My height is 5 feet 5 inches. My height is 5 feet 5 inches. This is actual value. This one is actual value. Or I can call it as theoretical value. That is nothing but true value. So 5 feet 5 inches will give the true value of my height. Now, one person came and he measures my height and he says that 5 feet 3 inches. Another person came and he measures my height and he says 4 feet 8 inches. Now, if you compare these values with the true value. Now, if I take this value and if I compare this with true value, it is very close to the true value. So, this value is called as accuracy. But if I compare this value with true value, they are not very close to each other. So, they are not accurate. I think it is clear for you now. Now, let us see about precision. Let us consider some examples. 4 feet 8 inches, 4 feet 7 inches, 4 feet 6 inches. Now, you compare all these values with the true value. You compare all these values with the true value. Now, if you see these ones, whether these values are close to the true value? No. So since they are not close to the true value, we will not call it as accuracy. Then you see this 4 feet 8 inches. Compare with this 4 feet 7 inches. Compare with this 4 feet 6 inches. Now these are what? Close to each other. These values are close to each other. Clear? So this what we can call it as precision. We can call it as precision. Clear? Now we will see an example comparing with accuracy and precision. Now let us consider a true value is 60 centimeters, and here I have given some values. In this, if I compare these values with the true value, that is which one is accuracy and which one is precision. Now if I take these two values, they are very close to true value. These values are very close to true value, so I can call it as accuracy. But if I compare all these values, they are not close to each other. So that is no, it is not precise. It is not precise. Next, we take these values. In this, if I compare all these values with true value, they are not close to each other, so they are not accurate. But if I compare all these values, you see they are very close to each other, so it precise. Similarly, take these values and compare with the true values. They are all close to true values, so they are accurate. Now you will compare these values, they are also close to each other, so precise. Now you take these examples, compare with the true values, they are not close to true value, so not accurate. Now you compare these values, see they are not close to each other, not precise. They are not precise. Next, in your textbook, one example is given, a visual example. Let us consider a target shooting. Target shooting. At the center, you have one point that is called bull's eye. We will call it as bull's eye. This is a nothing but what? Target, that is true value. That is true value. These are all shots. These are all shots. Now you see whether according to this diagram, whether both having accuracy and precise. You see that these shots are not close to the target. Same time, they are not close. These shots are not close among themselves. That means these shots are not close to the target, so what accuracy is not there. And these shots are not close together, so precision is also not there. Next, we take another diagram. This one is a target. Now these are shots. Now you see here, these shots are not close to the target, so they are not accurate. But all these shots are close together, so I can tell precise. Understood? You take another diagram. This one is a target, and all the shots are here. All the shots are on the or near to the target. Now you see, all the shots are very close to the target, so it is accurate. Same thing, all the shots are very close together, so I can call it as precise. It is clear? A numerical example. The true value of a certain length is near 5.678 centimeter. In one experiment, using a measuring instrument of resolution 0.1 centimeter, the measured value is found to be 5.5 centimeter. In another experiment, using a measuring instrument of greater resolution, say 0.01 centimeter, the length is found to be 5.38 centimeter. We find that the first measurement is more accurate as it is closer to the true value, but it has lesser precision. On the contrary, the second measurement is less accurate, but it is more precise. So now, errors in measurement. What is an error? The uncertainty in measurement is called an error. Now, there are three types of errors. One is systematic errors. Next one is random errors. And the last one is gross errors. So there are three types of errors. One systematic error, random error, and the last one is gross error. So systematic error means error consistent. Error consistent. Systematic error means error consistent. Consistent is nothing but constant. In random error, I can rectify this error by taking average. I can rectify this error by taking average. Gross error is nothing but personal error. Gross error is nothing but personal error caused by human mistake. Caused by human mistake. In experiment, the same type of error occurs repeatedly from beginning to end, then it is called as systematic error. For example, you take an analog machine. You take an analog machine. In that, the needle shows 0.3 kilogram. The needle shows 0.3 kilogram. Now I want to measure my weight. Actually, my actual weight is 60 kg. My actual weight is 60 kg. Now I am standing on this machine and I am weighing, and the machine shows 60.3 kilograms. Like that, if my son stands on this machine and it shows 50.3 kilograms, my son's actual weight is 50, but on the machine the needle shows 50.3 kilograms. Now this machine shows excess of 0.3 kilograms. It shows excess of 0.3 kilograms. This error, what we can call it as systematic error. Now let us see these three diagrams. These three diagrams represent our meter scale. In the first diagram, you see some readings are or not. Some readings are or not. The second meter scale represents, that is, it was broken. It was broken. Now, with the help of these two scales, if I measure any length of the object, whether I can able to get accurately, no. Only error will occur. This error we can call it as instrumental error. How to minimize the error? To minimize the error, we have to choose in such a way that the instrument must be proper like this. This is called as instrumental error. While performing an experiment, first we have to check whether the instrument is properly arranged or not. For example, while performing an experiment with calorimeter, first you must check whether it is properly insulated or not. That means, now this is a calorimeter made up of copper. Now inside hot water is there. This calorimeter is kept in a wood. Now this is calorimeter and this one is wood. We must check whether this calorimeter is properly insulated or not. That is, here it should be insulated like this. It may be of cotton or wool. Why we have to insulate? Because to avoid from heat loss, that is radiation loss. For that, we have to be insulated. For example, you take simple pendulum. You take a simple pendulum. So, if a person doesn't know how to set up the experiment, or they may not know how to find out the oscillations. They don't know how to find out the oscillations, or they may not know how to find out or how to take the time or how to find out the time period. Then these things, what we can call it as personal error. For example, changing temperature, pressure or humidity during measurement will affect the result of the measurement. For example, you take ball ring experiment. Before heating, the ball enters into the ring. But after heating the ball doesn't enter into the ring because due to thermal expansion. Because due to thermal expansion. The least count of meter scale is 1 millimeter, and for screw gauge it is 0.01 millimeter, and for vernier caliper it is 0.1 millimeter. Suppose if I want to find out the thickness of a wire or thickness of a paper, this thickness are less than 1 millimeter. This thickness are less than 1 millimeter. Suppose if I measure this thickness with the help of meter scale, can I measure it correctly? No, error will occur. Suppose if I measure a screw gauge or vernier caliper, I can find out the thickness of wire or copper. If I measure with the help of meter scale, an error occurs. That error, what we can call it as least count error. Suppose in physics lab, when you are doing an electronic experiment like PN junction diode. So while taking reading, suddenly there is a current fluctuation occurs, but we don't know. But we are going on taking reading. What will happen? There will be some error occurs. That error, what we can call it as random error or chance error. For example, you take a screw gauge. I want to find out the thickness of a wire. So while you are taking the measurement, you will not be taking in one particular place. So you will be taking in 4 or 5 places on the wire. So one reading, for example, for one set you will be taking as one reading, it will be A1. The other time it is A2. Then third time you are taking it as A3. And fourth time it is A4. And fifth time it is A5. Now I want to take down the average for this. So A1 plus A2 plus A3 plus A4 plus A5 divided by 5. This error, what we can call it as random errors. Suppose we are having n set of readings. That is A1, A2, A3 up to An. Now we find out the arithmetic mean. So A1 plus A2 plus A3 plus An divided by n. This I can rewrite as summation of Ai, I is equal to 1 to n divided by n. This arithmetic mean is taken as the best possible true value of the quantity. In spectrometer, we must adjust collimator, telescope, then we must adjust prism table before doing the experiment. Suppose if you are not doing it, then we will get an error. The focal length of lens is 9.6 centimeter, and if I write F is the current focal length is 6.9 centimeter, then I will be getting an error. If I substitute the value in calculation wrongly, then I will be getting an error. These errors are called as gross errors. Now we will discuss about error analysis. There are 4 types of error analysis. 1. Absolute error. Second, mean absolute error. Third one is relative error. Fourth one, percentage error. Let us consider an example, a pen. The actual length of this pen is 4 cm. When I am taking reading, I am getting 2, 3, 4, 5, 6. These are all my readings. But these readings are not equal to the actual value. So to get the actual value, what I should do is you must find out the mean or average. This 4 is making about actual value now. Here, so you will compare this reading with the actual value. There are some errors. What are the errors? I am getting it 4 minus 2. 4 minus 3, 4 minus 4, 4 minus 5, 4 minus 6. So these are all my errors. Clear? Now, so this one is what? I can call it as this way. I can call it as measured value. I can call it as measured value. This code, that is mean, I can call it as true value. I can call it as a true value. Here I took difference. This difference, what I am getting is absolute error. You can call it as what? Absolute error. You can get it as absolute error. Now, what is absolute error? Absolute error is equal to 4 represents what? True value. So true value minus this 2, 3, 4, 5, 6 represents measured value. So I can say absolute error is equal to true value minus measured value. It is clear. Now these are all absolute error. Now to take mean for this absolute error, that will give mean absolute error. Mean absolute error. So always the absolute error must be added. So here minus sign is there. So for that you take modulus. And then divided by 5. You will get what? So 6 by 5, that is equal to 1.2. This 1.2 is nothing but what? Mean absolute error. Next we will go for relative error. The ratio of mean absolute error is true value is called relative error. So I can write relative error is equal to 1.2 divided by 4. That is 0.3. Now we will go for percentage error. So percentage error is equal to multiply the relative error into 100. So I can write 0.3 into 100, that will give 30%. This is about percentage error. This is a given value. For we are having n number of values. Then how I can write absolute error, mean absolute error, relative error and percentage error. Now we will go for absolute error. We are having n number of values. Let it be A1, A2, like that AN. Next step what we will do is we will add and divide by 5 in here. But here we are having n number of values, so it will be divided by n. So A1 plus A2 plus AN divided by n. This part I can write it as summation of I represent 1 to n divided by n. This will give AN. The AN is nothing but true value. Understood? Now, up to this I clear here. Then what we are doing is absolute error. So I can write now this 4 represents what? AN minus that 2 represents the first value. That means first value is what? A1. That means is what? Absolute error. Absolute error should be represented by delta. So we are subtracting the first value, so I am writing it as A1. Then for second value, AM minus A2 is equal to delta AP. Similarly, those AM minus AN will be equal to delta AM. This is what? Absolute error. Now we will go for mean absolute error. So for mean absolute error, what we should do? We should take the modulus. So modulus of each one. Modulus of each one. Divided by n. Let me write it This clear now. Then we are going to be going for relative error. What is relative error? Mean absolute error divided by what? True value. So I can write relative error is equal to delta am divided by am. This is what? Relative error. Next we will go for percentage error. In percentage error, what will be? Percentage error is equal to what is the value of error? Relative error. So delta am by am into 100%. This is about relative error. We will see an example, that is 1.4, page number 22. In a series of successive measurements in an experiment, the readings of the period of oscillation of a simple pendulum were found to be 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds, and 2.80 seconds. Calculate the mean value of the period of oscillation, the absolute error in each measurement, the mean absolute error, the relative error, and finally the percentage error. So what is given? Time period, that is T1 at 2.63 seconds. So T2 is equal to 2.56 seconds. T3 2.42 seconds. T4 it is 2.71 seconds, and T5 it is 2.80 seconds. What is the first question? They also find out the mean value. So I can write EM, mean value of the given time period. How to find out mean value? You add all these numbers and divide by 5. So I can write T1 plus T2 plus T3 plus T4 plus T5 divided by 5. So 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 divided by 5. So 2.63, 2.56, 2.42, 2.71, 2.80. So 13.12 divided by 5. So just this value you round up and say it will be what? 2.62 seconds. This will be what? Mean value. So for mean value we just become 2.62 seconds. Here. Now next we will be going to absolute error. How to find out the absolute error? From the true value, subtract the measured value. To subtract the measured value. That will give the absolute error. So delta P1 is equal to 2.62 minus 2.63. That will become minus 2.63. So minus 0.01. Delta T2 2.62 minus 2.56. 2.62 2.56. So 0.06 seconds. Delta T3 2.62 minus 2.42. 2.62 2.42. So 0.20 seconds. Delta T4 is equal to 2.62 minus 2.71. 2.62 2.71. So minus 0.09 second. Delta T5 is equal to 2.62 minus 2.80. So 2.80 minus 2.62. .18 seconds. This will give the absolute error. Next, we are going for mean absolute error. Mean absolute error. Delta Tm. So, mean absolute error means you add all these things and divide by 5. Here you must be careful that first of all you must take modulus of each value and then you must add. So, modulus of minus 0.01 is 0.01 plus modulus of 0.06 is 0.06. Like that you must write it 0.20 plus 0.09 plus 0.18 divided by 5. Now you add all these numbers 0.01, 0.06, 0.20, 0.09, 0.18. So 0.54 divided by 5. So round it up and I am getting in a 0.11 second. This will be delta Tm. Next one is, fourth one is the relative error. So relative error is equal to mean absolute error divided by the true value, that is Tm. So 0.11 divided by 2.62, that is equal to, here 2 is 1 for sure, so 11 divided by 262, so 0.0, so 262. So 41048. So you will get 0.041. So I can write it as 0.04 second. This will be what? Relative error. Next, they ask to find out the percentage error. Percentage error. So percentage error is equal to 0.04 into 100. That will give what? 4%. So therefore, the time period of simple pendulum, time period of simple pendulum is equal to 2.62 plus or minus 4%. Plus or minus 4%.